All right, so in this lesson we're going to talk about the fundamental theorem of algebra and some properties of it. Basically, this theorem just says that if you have a polynomial where the degree, which again the degree is the highest exponent on your variable x, if the degree is positive, 1 or higher, then you're going to have at least one zero in the complex number system. So it's a basic idea, but we know that if you have a degree of 1, you got 1 0. If you got a degree of 2, you've got 2 zeros. If the degree is 3, you got 3 zeros, and so on and so on. So this is just a basic theorem that we start with to discuss how many zeros we have based off of the degree. All right, so first, right here we got this problem. We want to find the factors of this as a product. So we're going to write this as a product of its factors, meaning in factored form, and list all those zeros. All right, so first thing we need to do is figure out what are the possible zeros. Well, we've got 8 as the constant term, so the factors of 8 are 1, 2, 4, and 8. So we write all those over the factors of the lead coefficient, which is 1. So of course that's positive negative 1, positive negative 2, positive negative 4, positive negative 8. So we have 8 possible zeros that could be rational zeros. So now to figure out where, which one of these actually is a zero, let's graph the function. So x to the 5th plus x to the 3rd plus 2x squared minus 12x plus 8. Let's see, where does it look like it's crossing at any of these values? It looks like it's hitting -2, going through there, and it looks like it might be bouncing off of 1. Okay, so let's figure out if those are actual zeros by doing synthetic division. So let's try -2. All right, so our coefficients are 1, 1, 2x squared, negative 12x's, and 8 constants. Oh, but wait, we don't have an x to the 4th. So what do we got to do? We got to leave a 0, right? So you can't forget those zeros if you've got a variable that's missing. 1x to the 5th, 0x to the 4th, right? 1x cubed, 2x squared, negative 12x's, and then 8 x to the zeros. All right, renamming 1 times -2 is -2, 0 minus 2 is -2, times -2 is 4, 1 plus 4 is 5, times -2 is -10, -10 plus 2 is -8, times -2 is positive 16, minus 12 is 4, 4 times -2 is -8, and 8 minus 8 gives us 0. Awesome, so our remainder of 0 means that one of our zeros, okay, so it says to list all the zeros, so there's one of them, -2. Okay, now we can try synthetic division again. It looks like the graph touches at 1, which is another one of our possibilities, so let's try 1. We're going to do 1 times 1 is 1, minus 2 is -1, times 1 is -1, 5 minus 1 is 4, times 1 is 4, -8 plus 4 is -4, times 1 is -4, and 4 minus 4 is 0. Awesome, so we found another one. Okay, now we know we're going to have 5 total zeros, right? Because the degree is a 5. So those are 2 of them. Now, one thing we got to remember that we talked about way back in section 1 of chapter 2 is the multiplicative zeros, right? So we talked about the behavior at the x-axis tells us how many times that 0 is a 0, right? So remember, whenever it passes straight through, like it does at -2, when it goes straight through, that means that is just a 0 one time. Okay, it's only 0 once. But if it bounces off at that value, then that's going to be a 0 an even number of times, 2 times, maybe 4, 6. Okay, so right here where it looks like it bounces off at 1, that tells us that 1 should be a 0 an even number of times. So we should have 1 as a 0 a second time. So knowing that, we can do synthetic division another time and use 1 again, because it should be a 0 multiple times. So bring down your 1 times 1 is 1. 1 minus 1 is 0, 0 times 1 is 0, 4 minus 0 is 4, and 1 times 4 is 4. -4 plus 4 is 0. All right, so see, we got our 1 is a 0 a second time. Try I put a -1 up here, that should be positive 1. First mistake of the lesson. All right, so we got 1 is a 0 twice. You can write 1 twice, or you can try 1 multiplicity 2, which means it's 1's a 0 twice. All right, so now let's look at what we've got left. Running out of room down here. So what we've got left, we went from a 5th degree right here to a 4th degree to a 3rd degree to now a 2nd degree. So this is 1x squared plus 0x plus 4. All right, so we've got to take that left, try to factor it. Now, I'll save you some time. That's not going to factor. What multiplies by 4 and adds up to 0? Nothing exists. So we need to set it equal to 0 and solve. X squared plus 4 equals 0. Subtract 4 and take the square root. We got the plus and minus. So we get x equals plus and minus square root of negative 4 is 2i. All right, so those are our other two zeros. Positive 2i and negative 2i. Right, that's the zeros, so those are our list of zeros. Now, if we want to write it as a product of factors, here's how we're going to do that. We're going to write f of x equals, and we're just going to write in our parentheses x minus each of the factors. So x minus negative 2 is really x plus 2. We got x minus 1. We have x minus 1 again. So we can write an x minus 1 a second time, or we can just put a squared on that one. So that means we have x minus 1 twice. And then we've got x minus 2i and x minus negative 2i, which will be x plus 2i. All right, so there is how we would write the function as a product of factors. You could also leave it as, instead of splitting it up into minus 2i and positive 2i, you could just leave it as x squared plus 4, since that doesn't factor anymore. I would accept either answer, and we'll talk more in another example about the difference and when one is more appropriate. So if you left it like this, that's as factored as it can get when you're just using real numbers with no imaginaries. So if you leave it like that, that's a good answer too. All right, just depends on if you're factoring it completely or just factoring it using real numbers. All right, so I'm going to pause the video, let you guys go ahead and try this next one down here. Just follow the same process and see if you can get all 4 of the zeros on this one. All right, so here you can see the graph of the function and also the possible rational zeros. So we look at the graph and see that it looks like it's bouncing off at 2, which gives us an idea that we're going to have 2 as a 0 twice instead of just once. So we do synthetic division with 2. We get it as a 0. We try it a second time and it works as 0 second time, which is what we expected. So 2 of our zeros, 2 of the 4 are 2. And then we take the factor that's left, x squared plus 4, set it equal to 0, and solve it to find the other 2 zeros, which, just like the last problem, is positive 2i and negative 2i. So our zeros are 2, the multiplicity of 2, 2i, and negative 2i. And then in factored form, we write x minus 2 squared and x squared plus 4. Again, you could write, instead of x squared plus 4, x plus 2i and x minus 2i if you wanted to factor it down completely. Just depends if you want to use imaginaries or not. All right? And you say, well, when do I know? Well, the directions will tell you. Usually, if they don't say to factor it completely, then writing it as factored as possible in real number form, like I have it right here, is what you want to do. All right, so let's look at example 2. So right here, we want to find a polynomial when I tell you the zeros. All right, so it says find a cubic. Cubic means x to the 3rd. Right, that tells us the degree is going to be to the 3rd. A cubic polynomial function f with real coefficients, so that 2 and 1 minus I are zeros. All right, and f of 1 has to equal 3. So when we plug in 1, that means when we plug in 1 to the function, we want it to spit out 3. Okay, so here's what we're going to do. Just like we worked on the last problem, if you know the zeros, we can write the factors by just doing x minus the zeros. So I'm going to say my function is going to be x minus 2 is a 0, x minus 1 minus I. Okay, yes, I got to put the 1 minus I in parentheses. I'm subtracting the whole thing. Now, here's one thing that you got to be aware of. Anytime you have an imaginary 0, okay, which we do right here, 1 minus I. Anytime you have an imaginary as a 0, the conjugate has to be a 0 also. The conjugate of that complex number also has to be a 0. So the conjugate of 1 minus I is 1 plus I. So then we're also going to say x minus 1 plus I in parentheses. All right. So now at this point, the only thing we need to worry about is that we've got to have some kind of coefficient out here, some kind of lead coefficient. We don't know what that is, so we're just going to put a for the moment, and we'll figure out what it is here in a second. So now what we want to do is multiply and FOIL everything out in order to get the factors to go away and have it as simplified as possible. So the first thing we want to do is multiply the two terms that have an x minus the imaginary numbers. All right, so simplest way to do this is to distribute the minus 1 minus a minus I is plus I. And then same thing over here, minus 1 and minus I is minus I. Okay, now you really have a trinomial times a trinomial. All right, so when you're multiplying trinomials, you've got to do 3 things times 3 things, right? So we know we're going to get 9 terms total whenever we do this. All right, so let's go ahead and start. We got x times x is x squared. X times minus 1 is minus x times minus I is minus ix or xi. Either way is fine. All right, and we're going to get a lot of things that are going to cancel out right here. So you say there's 9 terms, oh my goodness, but lots of it's going to cancel. Minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. And then minus 1 times minus I is plus I. All right, now multiply by I times x is positive ix. I times minus 1 is minus I. And then plus I times minus I is minus I squared. Okay, so let's look and see what's going to cancel real quick. We've got a positive ix and a minus ix. All right, and then we've got a minus I and a positive I that are going to cancel out. So that's going to give us a bunch of things that will cancel, and everything else should still be there, I believe. So we've got x squared minus x and minus x give us minus 2x. We use those, minus 2x. And then we've got plus 1. And remember, minus I squared. Well, I squared is really negative 1. So this is really minus negative 1. So that's really a plus 1, right? So we've really got plus 1 plus 1. So this is really x squared minus 2x plus 2. All right, so those two multiply together to give us that, and then we've got the x minus 2 right here. So now we've got to go ahead and distribute the x minus 2 to all 3 of these terms also. And we've still got the a out front, which we'll worry about here in a second. So x times all of these, so we give all 3 of these an x. It's going to be x cubed minus 2x squared plus 2x. And then give all of them a minus 2. Minus 2x squared. Minus 2 times minus 2 is 4x. And then minus 2 times positive 2 is minus 4. Now we combine like terms, x cubed. We got minus 2x squared and minus 2x squared that give us minus 4x squared. We got 2x and 4x that give us 6x. And we got minus 4. Okay, so remember we've got all this times the a to equal f of x, right? So now here's the last step you got to do. You got to figure out what is that Lie coefficient. And we're going to use this part up here, the f of 1 equals 3, to figure that out. So we know that if we plug in 1, we want it to spit out 3. So we're going to take that function, running out of room here a little bit, and we're going to plug in 3 for f of x, leave the a, and then plug in 1 for all the x's. So we got 1 to the third minus 4 times 1 squared plus 6 times 1 minus 4. All right, and whenever we calculate all this in here, we're going to get 1 minus 4 plus 6 minus 4. So 3 is going to equal a times 1 minus 4 plus 6 minus 4 is going to give us negative 1. So negative 1 times a is negative a, divide by the negative 1, divide by negative 1. So a has got to equal negative 3. So now we can rewrite our function right here. Well, maybe we can, maybe we can't. We can rewrite the function. I'm just going to erase the a. And now we know that that's a negative 3. Okay, so you can go through now and distribute the negative 3 to every one of the terms. And whenever you do that, you would get negative 3x to the third plus 12x squared minus 18x plus 12. Okay, I believe that's right. Let me check, double check. Yeah. All right, so there's our function that has 2 and 1 minus I is zeros, and f of 1 equals 3. All right, so I know that's a big, long process, but it's just a bunch of multiplying and simplifying, a lot of algebra stuff, just a lot of steps to it. Okay, so let you guys try this one right here. Go ahead and pause the video, give it a try, come help if you need it, and then I'll go over it. Okay, so we've got a 4th degree polynomial, so we've got 4 zeros. They tell us it's got to have zeros at -1, 1, and 3i. So if 3i is a 0, we know negative 3i is also a 0. So our factors are going to be x plus 1, x minus 1, x plus 3i, and x minus 3i. So we multiply all those together with the a. Go ahead and distribute or FOIL x plus 1 and x minus 1. Notice those are conjugates, right? Anytime you multiply conjugates, you don't need to worry about the middle terms, okay, because they're going to cancel. So you can just do x times x and 1 times -1. We talked about that when we did dividing complex numbers. Same thing with x plus 3i, x minus 3i. Just do x times x and 3i times minus 3i, and you get x squared minus 9i squared. Of course, I squared is -1. So from the second step to the third, we change I squared to -1, and -1 times -9 is +9. Then we just FOIL x squared minus 1 and x squared plus 9, and we get x to the 4th plus 8x squared minus 9. So at that point, we need to solve for a. So we plug in 3 for f of x, and we plug in 2 for x, and we do all the math. You can go through that process, and we end up getting 39 times a equals 3. So we divide by 39, and 3 over 39 reduces to 1 over 13. So we plug that back in as a in our function, and then distribute 1/13 to all 3 of the terms. So 1/13 x to the 4th plus 8/13 x squared minus 9/13 would be the function. Yes, it's kind of weird. There's a fraction on all the terms. That can happen. Not common, but it can happen sometimes. Okay, let's roll on. Just a couple more examples. So right here, this is where we're going to talk about how far to factor something. So we want to factor this in 3 different ways. So it says first, factor as a product of irreducible numbers over the rational numbers. So just to where we have rational numbers, remember numbers you can write as a fraction, that means no square roots or no imaginaries. So if we factor this, okay, one thing to realize is this is a trinomial. Okay, so this is something kind of new, so it's not complicated, but it is new. So normally when we see a trinomial, we think, oh, factor doing x box or slide and divide. You can still do it, okay? You look at the but it's x to the 4th, right? Well, you can still do it as long as that lead exponent, 4, is twice as much as the exponent on the middle term. Well, is 4 twice as much as 2? Yes, okay? So you can still try to factor it with x box. If that was 4 and 3, then you couldn't do it. Or if it was 4 and x to the 1st, x to the 4th and x to the 1st, you couldn't do it. But as long as that first term is twice as high a degree as the middle term, then you can still do it with x box. Okay, so what multiplies to be 20 and subtracts to be 1? Oh, 5 and 4. So I'm going to say a 5 in one and a 4 in the other. Now the difference now that we're not talking about, it's not x squared minus x. The difference is instead of putting x at the front of each, you've got to put x squared at the front of each. Okay, so whatever's right there in the middle, whatever degree that is, that's what you put at the beginning. All right, normally it was just x, so we put x at the beginning. Well, now it's x squared, so we've got to put an x squared there. All right, and then we're going to use a minus on just one of them, so we put a minus on the big one, a plus on the other. All right, now could we factor any further? All right, can we factor any further? Well, these are just 2 terms, so you see if you have a difference of squares. Well, the x squared plus 4 is not a difference, so it's not a difference of squares. X squared minus 5 is a difference, but 5 isn't a perfect square, so you can't factor it using a difference of squares. All right, so this is as factored as it gets to factor it over the rational numbers. We can't do anything else to it to make it rational or to make it any more factored without using numbers that are irrational. All right, so now B says as a product of factors irreducible over the real numbers. So now if it's real numbers, that means we can use numbers that are irrational. Okay, irrational numbers are part of the real number system. Irrationals are like square root of 2, pi, stuff like that, are decimals that go on forever that you can't write as a fraction. So what we can do here is simply split up x squared minus 5 by using a difference of squares. Okay, so essentially we're asking what is it that I have to square to get 5? It's not a perfect square like 4. 4 you would say, oh, square 2, and it'll give you 4. What would I have to square to get 5? Well, I would have to square the square root of 5, right? The square root of 5 squared is what would give me 5. So I'm going to use the square root of 5 in here, add the square root of 5, and subtract the square root of 5. So that's how I can factor x squared minus 5 down further, by using real numbers, right? So square root of 5 is irrational, but it is a real number. So when I'm factoring over numbers that are real, I can do it that way. And then x squared plus 4, I can't factor it anymore using real numbers, okay? So that's as factored as it gets by using real numbers. C part says to factor it completely. So completely factored means over the complex number system. So you can use imaginaries, you can use irrational numbers, whatever. So we've already got this part factored down as much as possible. X squared plus 4. We can factor it down into x plus 2i and x minus 2i, as we've seen in the other problems, right? When you have a sum of squares, you pretend it's a difference, but just put i's with your number. So x squared minus 4, if we factored x squared minus 4, we would factor into x plus 2 and x minus 2. Well, if it's a sum of squares, just throw an I in there with the 2's. Pretend it's a difference of squares and just put i's with the 2's. Okay, so that is how we would factor it completely over the real number, or over the complex number system. All right, so I'm going to go ahead and pause it and let you all try the next problem, and we'll go over it. Real quick, when we factor this, you get x squared minus 7 and x squared plus 1. Well, that's as far as you can do it over the the rational numbers without having any square roots. B part, you can simplify x squared minus 7 into x plus square root of 7 and x minus square root of 7 to do it over the real numbers. Of course, x squared plus 1 is still x squared plus 1. And then in C part, you can split up x squared plus 1 into x plus I and x minus I, and that's completely factored. All right, so last kind of problem we'll do, and this will be a pretty lengthy kind of process, so just go with me here. It's pretty logical though, so we want to find all the zeros given that 1 plus 3i is a 0 of f. Okay, so remember, if 1 plus 3i is a 0, the conjugate's also got to be a 0, right? Anytime imaginary is 0, you've got to have the conjugate as a 0. So we know we're going to have 1 plus 3i is a 0 and 1 minus 3i is a 0. Sorry, my fault. X minus 1 plus 3i and x minus 1 minus 3i are both zeros. All right, so now we're going to go through the process of multiplying everything out. X minus 1 minus 3i, x minus 1 plus 3i. Okay, so whenever we multiply all of this, we're going to get x times x is x squared, x times minus 1 is minus x. We get plus 3xi, or 3ix, however you want to do it. Minus 1 times x, minus x. Minus 1 times minus 1 is plus 1. Minus 1 times 3i is minus 3i. Minus 3i times x is minus 3xi. Minus 3i times minus 1 is plus 3i. And minus 3i times plus 3i is minus 9i squared. All right, then you combine your like terms and see what cancels. So plus 3xi and minus 3xi will cancel. Plus 3i minus 3i will cancel. So we got x squared. We got minus x and minus x is minus 2x. And then we've got plus 1. And we got minus 9i squared. Well, remember that I squared is really a minus 1. So that's going to turn the minus 9 into a plus 9. So this is really x squared minus 2x plus 10. Okay, so we've got some type of factor now that we know should go into this function evenly, right? We know x squared minus 2x plus 10 should go into that evenly because both of the factors of x squared minus 2x plus 10 are factors of that function. So what we can do to figure out the rest of the function to find the other zeros is divide x to the fourth, the whole function f, by x squared minus 2x plus 10, because it should divide into it evenly, and we'll get what's left. But because this is not a linear factor, x squared minus 2x plus 10, we've got to do long division instead of synthetic division. So this is where long division comes in. X to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. All right, so now we got to figure out what will go into x to the fourth when we put x squared into x to the fourth. What's left? X squared. X squared times x squared is x to the fourth. X squared times minus 2x is minus 2x cubed. And then multiply by 10x squared. Now we go through and subtract everything, right? So x to the fourth minus x to the fourth cancels. Minus 3 minus minus 2, x to the plus 2, so that's minus 1x cubed. And then 6 minus 10 is minus 4x squared. Bring down your 2x and go through the process again. What do you multiply x squared by to get minus x cubed? Negative x. Negative x times everything. Negative x cubed, positive 2x squared, and minus 10x. Now when you go through and subtract everything, all right, you're going to add that, subtract this, add this. So we get minus 6x squared, and then we get 12x, and you bring down to 60. What multiplies x squared to get minus 6x squared? Minus 6. All right, now I'm running out of room here. Let me move this down to the next problem. Sorry about that. All right, so multiply everything by minus 6, minus 6x squared, plus 12x, and minus 60. All right, so remember, we realized it was supposed to divide it evenly, right? So watch what happens. When we subtract everything, it all cancels out and leaves 0, which is what we expected to happen because we knew that those were factors. So since they're factors, they should divide into the function evenly. So what's left is x squared minus x minus 6. So we need to take x squared minus x minus 6 and factor it further to find our other zeros. What multiplies to be 6 and subtracts to be 1. 3 and 2. So we got x and 3, and we got x and 2. We put the minus on the big number, plus on the other one, and that's as factored as it gets. So we set each factor equal to 0. X equals 3, and x equals negative 2. All right, so the question said to find all the zeros. All right, so our zeros now we know are 3, negative 2, 1 plus 3i, and 1 minus 3i. All right, that's all of our zeros. So go ahead and pause the video and try the next one, and I'll help you out with it if you need it. All right, so on this one, you had to do x minus 5 plus 2i and x minus 5 minus 2i because we knew 5 plus 2i was a 0, so 5 minus 2i has got to be a 0 also. So whenever we multiply all that stuff out, it's going to simplify down to x squared minus 10x plus 29, which you can see right here. And so we divide that into the original factor, the original function to figure out the other factor of the function. Because we know one factor, we can divide it into it to find the other factor. Just like 2 is a factor of 8, so we can divide 8 by 2 and find the other factor is 4. So that's the same kind of thing we're doing just with polynomials. So we go through our process of long division. Right here you can see the steps. I'm not going to walk you through the whole thing. And whenever we get done, we get x plus 3 as the only other factor. So set x plus 3 equals 0, solve, and our other 0 is negative 3. So our zeros are negative 3, 5 plus 2i, and 5 minus 2i. All right, that's it for today. I know this is a long lesson. Let me know if you have any questions or need any help.